for the advanced Python topics in Python, and we are now into the activity of the introduction to bitwise operators, and this is one of the activities that I really liked doing because it is very similar to the previous math uh, subjects that we had. Math 1, I think, where we're doing where we're computing for the bits, and then we are converting them to the text, something, but it's in powers of 10, or powers of base of 10, or it's a base of 2, so which was pretty interesting. So anyway, we have around, let's see, 14 sections, and hopefully you can get through that in just 15 minutes. Okay, so first we're going to just click save and submit. Okay, so for the base 2 number system, which is the binaries, so 1010, we have to take a look at the examples in the editor and then try to understand how it's. So 1 is 1 because it's the order is, the value is like, this is 1, the next is 2, and then 4, then 8, then 16, 32, 64, and so on and so forth. So for this one's, the value of 1 is in 0, and then we have assigned 1 to 2, so the value is 2. This one is 1, this one is 2, so 1 plus 2 is 3. So 1, 2, and then 4. So 1, 2, and 4. So we have 1 plus 2 is equals to 0, so that's 0. And then this one is 4, so 4 plus 1 is equals to 5, and so on and so forth. Just submit. Okay, now we are going to do what we've done earlier, but this time we are going to count, and we are using this format with the 0 and then the B. And let's just reset this for a second. Yeah, so 1, 2, and 3 were already done, and we have to fill out from 4 to 12, and these are my answers. So let's get into, for example, 9. So because it's 1, 2, 4, and 8, so 8 plus 1 is 9. 1, 2, 4, 8, so 10 would be 8 plus 2. And then 11 would be 1, 2, 4, 8. So 8 plus 2, and that was 1, so that's 11. And then for 12, 1, 2, 4, 8, so 8 plus 4 is 12. Submit. Okay, now for the binary or the bin function, it takes an integer as an input, and then it returns the binary representation of that integer. So like this one, the binary of 1, or what is the binary conversion of the number 2, or the binary conversion of number 4, and these are the results right here. So they are now printed in binary. Okay, so next what about if we want to convert the binary into integers? So, or in the base of 10. So we are doing it in this format. So this is the number, or this is the bit, and then the base that it's in. So binary is always in the base of 2, and this one. And we are going to print them out like this, and that is their value. Next, is the slide to the left and slide to the right. So we are going to use these operators to shift the bits of a number over by designated number of slots. So we're moving it to the right by 2 places, or moving it to the left by 2. And that we can only do this into integers. So the instruction is to shift the variable shift underscore right to the right twice. That's it. And then the one to the left twice. So what would happen? So if we are going to shift this to the right, we're going to shift this to the left. So let's click save and submit. So now this move to the right. So there are no more 2 zeros here, but rather it's now 1 and 1. And then since we shifted to the left, as you can see, it starts here, it's 1, and now it's 1 and 0, 0. Because we shifted 2 places to the left. Next is AND operator. So it's very similar to the logic operators that we had earlier. So for this one, both of them has to be equal to 1, so that the result would be 1. And then other than that, if it doesn't satisfy that condition, then the rest it will always be 0. So like this, so 0 and 1 is 0, 1 and 1 is 1, 0 and 1 is 0, 1 and 1 is 1, 0 and 0 is still 0, and so on and so forth. Okay, so printing out the result of this one is OB1 0B100. Why? Because 0 and 1 is 0, 1 and 0 is 0, 1 and 1 is 1, and then since this one doesn't have, there's no bit here anymore, it's automatically 0, so 1 and 0 is 0. Okay, now for OR, this is the given. So as long as there has to be at least one in it, then it will automatically be equal to 1. So it will only become 0 if both of them are 0. So to practice, just print this. Right, next is the exclusive OR operator, where this is the condition. So only one of them should be, one of the pair should be 1 and one of the pair is 0. It can't be both 0 and it can't be both 1s. Okay, so for this one, so 0 and 1, that would be 1. 1 and 0 is 1. 1 and 1 is 0, then 1 and nothing here, so 0 is another 1. So we have the 1 0 1 1. Next is the NOT operator. So it will flip the bit, all of the bits in that single number. So I'm just going to click save and submit. And there you go. Now what is a bit mask? A variable that aids you with bitwise operation. It can help us turn specific bits on, turn others off, or just collect the data from an integer about which bits are on or off. So we have to define a function first, check underscore bit4 with the argument input. Now, if the bit is turned on, it will not print, and if it's turned off, it will return off. Okay, so how do we turn it on? By using the mask. So what does this mean? So if this is the value of variable a in binary, and assigning this into mask. What will happen? So it transforms these into ones, into three ones. Okay, next is to flipping them again, all of them. So the mask is always, for flipping it, the mask is always, the value is always all ones. Now we define a function called flipBit that takes the inputs number and the n. Now we're going to flip the nth bit and store it in result. So how to flip it? So we're going to use again mask, and we're going to flip the nth bit. Since we don't have an idea what that is, we're using this one by shifting it, going to the left, the less one, and we return it the result by calling bin underscore result, and then we're going to print the flip bit using this one. 100 is the number and 4 is the n. And there you go. So the next is, oh, introduction to classes. This is unit number 11 for the activity driving a car.